In this lesson, we're going to use trigonometric identities to solve some trig equations, all right? So we got some basic steps when we're solving trig equations. We want to simplify the trig expressions on each side so that we can get them down to as simple a form as possible. Then we want to isolate that trig expression and solve it. And we'll have a few other techniques as well. But let's see where that takes us. So we got 2 times the cosine squared equals 1. All right, so first thing we want to do is simplify this if possible, but it can't be simplified. That's pretty simple. And we'll notice the directions here. We want to find all the solutions to the equations on the interval 0 to 2 pi. All right, so remember, cosines of lots of different angles can be the same, but we just want to look at the angles on the first circle, the unit circle, 0 to 2 pi. All right, so let's get that cosine squared all by itself. Let's divide by 2. And we have cosine squared is equal to 1/2. And so now we want to get rid of the squared, just like we would do with lots of other equations. If it didn't have the cosine in it, we do the same thing. Square root. And that gives us cosine x equals the square root of 1/2, which is 1 over the square root of 2, square root at the top, square root at the bottom. And that can be simplified, rationalize the denominator so we recognize it, and that becomes square root of 2 over 2. Just remember, multiply by square root of 2 and square root of 2 on the bottom. All right, so we should recognize that, square root of 2 over 2. Remember, we're going to think unit circle here now. So let's sketch a unit circle, and we want to think about where we have a cosine. It's a beautiful unit circle there. And so where do we get a cosine that is the root 2 over 2? Well, that happens at the 45s. Remember, cosine on the unit circle is the x-coordinate. So cosine is positive right there at that 45, and right here, this negative 45. So these angles are pi over 4. And remember, we want our range here, the domain, to be between 0 and 2 pi. So we could call this negative pi over 4, but negative pi over 4 is not in that range. So we'll call this, going all the way around, this is 7 pi over 4. So the answer is x equals 2 answers, pi over 4 and 7 pi over 4. There you have it. Let's try some more. All right, here we want to get that sine all by itself, so let's divide by 2. And we have sine of pi over 5 equals negative root 3 over 2. Okay, and now so we need to find that negative root 3 over 2. We should recognize that. That should make us think of our 30, 60, 90 reference triangle here. And so negative, sine is the y value. Okay, actually let me write another step here before we go too far here. Okay, so we want to get rid of this sign here, S-I-N, all right? So what we need to do to get down to this stuff here is we need to take the inverse sign. So we have pi over 5 times x, that stuff on the inside, is equal to the inverse sign of negative root 3 over 2. All right, so we want to find out what angles have a sine of negative root 3 over 2. Sine is the y value, so that's going to be our larger side of our 30, 60, 90 triangle. So we're thinking over a half down to, there it is right there. And we're going over half down root 3 over 2 to get this angle right there. Those have a sine, a y value, negative root 3 over 2. This guy right here is 4/3 pi, or 4 pi over 3. This guy is 5/3 pi, or 5 pi over 3. So there's 2 angles on the unit circle that have this particular sign. So since there's 2 angles, we need to break this up into 2 equations. So we have pi over 5x could be equal to 4 pi over 3, or pi over 5x could be equal to 5 pi over 3. All right? Now we need to clean this up, finish it off. Let's do that by multiplying by the reciprocal. So if we multiply both sides by 5 over pi, because I want to get x all by itself, we'll get our answer. This becomes x. The pi's cancel. We end up with 20/3. Here, multiply by 5 over pi on both sides. And 5 over pi. Pi's cancel. And we end up with x equals 25/3. Two answers. There they are. All right, here's a crazy looking one. We've got sine cubed x plus sine x cosine squared plus 2 equals 1. So, a little crazy. We got a couple different things going on here. Remember, the first step there we were going to do is we're going to simplify this side. So we want to clean up this left side. So we notice that these have some common terms. So let's factor out a sine x, because there's a sine x in both of those. And what we're left with is a sine squared of x plus cosine squared of x plus 2 equals 1. So we just factored these two terms here. And why did we do that? Well, we see that it cleans up real nicely here. Sine squared plus cosine squared, that's just worth 1. So this is sine x times 1, which is just sine x. So right away, a lot of it just disappears because it's sine x times 1, and this whole bit here is worth 1. Okay? So minus 2, sine x equals negative 1. Now we need to go to our unit circle. And do take a moment to draw out this unit circle to make sure you're on the right track. Sine is the y value. Where is the y value equal to negative 1? There's only one point where sine is negative 1, and it's right down there at 3 pi over 2. So x equals 3 pi over 2. Again, the directions we're using is find all the answers within 0 to 2 pi. If we wanted all possible solutions, little side note here, we know that there's lots of angles that have a sine of negative 1, and then we could say that x is 3 pi over 2 plus 2 pi in. So if we kept going around the unit circle, we'd get another one. Or if we think about our graph, the sine wave will touch the y value here will be negative 1 at all of these values that are 2 pi away from 3/2 pi. So with the instructions given at the beginning there, we want just the answers between 0 and 2 pi. There's only one angle. If we want all the solutions, we'd have to tack on this 2 pi in because the period is 2 pi. Okay, now we're going to use our odd and even function identities. So here we have the sine of negative x equals 1/2. Before we go too far, we'd like that to be a positive x. Well, we know that sine is an odd function, as we mentioned previously. Since it's an odd function, this is equal to negative sine of x. For odd functions like x cubed, x to the 5th, things like that, when you put a negative inside, it ends up being the opposite of what it was originally. So that negative kind of pops out here. All right, so now let's go ahead and multiply by negative 1 to get this negative to the other side. Let's rewrite it as sine of x equals negative 1/2. Multiply both sides by negative 1. Now let's go to our unit circle. Where do we get a sine, which is the y value of negative 1/2? That's going to be down here on our 30-degree reference angle. Okay, because the y value is that short side, which is negative 1/2. And this is at pi over 6 less than the whole thing, so that's 11 pi over 6, because 12/6, which would be 2 pi. And this is 1 pi plus a 6, so this is 7/6 pi, or 7 pi over 6. All right, so there's our two answers. X equals 7 pi over 6, or 11 pi over 6. There are the answers between 0 and 2 pi. Now, the general solution, a little side note here again, if you wanted to list all the solutions for this, we'd have to say x equals 7 pi over 6 plus 2 pi n, or x equals 11 pi over 6 plus 2 pi n. All right, so that's how you would state the general solution there. Again, our instructions just wanted these two specific ones. Okay, our last couple examples here, we're going to do some factoring, all right? So we want to solve this, so the key is to factor it, because we got sine and cosine mixed up together. So we can't simplify anything. Go through all your identities. There's nothing that can be simplified, but we can pull out cosine of x here, leaving behind 2 sine x minus 1. Now notice this is equal to 0 already. If this wasn't equal to 0 and we want to use factoring, we need to set it equal to 0, because factoring doesn't work if we don't set it equal to 0. So we have something times something else equals 0. So if we use our zero product property, we know that cosine of x has to be equal to 0, or 2 sine x minus 1 equals 0. So we now need to solve both of these. So we're going to do our unit circle. So we ask ourselves, when is x equal to the inverse cosine of 0? In other words, what angles give us a cosine of 0? And the cosine is the x-coordinate, so that's right here and right here. Okay. When do we get a sine? Let's go ahead and solve this for sine. Add 1 to both sides, divide by 2. So sine x equals 1/2. So x is the inverse sine of 1/2. All right. So when do we get a sine of positive 1/2? Sine is the y value. That's up here. There's our 30, 60, 90 reference triangle. And up here. Okay. So we get the points. X equals, our first angle here is pi over 6. 30 degrees. We get one at pi over 2 up top here. Over here, this is pi over 6 less than a full pi, so that's 5 pi over 6. And 3 pi over 2 down at the bottom. There's our 4 angles between 0 and 2 pi. So 2 of them come from the first half, 2 of them come from the other factor. So that's how we use factoring. Make sure it's equal to 0, factor it, solve both equations, and make sure you list all of your possible answers. All right, one more here. So we have 2x squared, cosine x squared, minus sine x equals 1. So we can go through our different techniques we've used. Maybe we could simplify this. Well, you can't. They're different functions, so you can't combine them. Maybe you could... well, our only other idea is to factor it here. Okay, so we could try factoring. Can we pull out anything from these two? Nope, there's no common factor. And we got cosine, we got sine, so we're just messed up here. Well, we do have a way, though, of changing this cosine squared into sine squared. Remember that? We had an identity that said cosine squared x equals 1 minus sine squared. That's just the Pythagorean identity kind of tweaked around there, solved for cosine squared. All right, so let's try using that, and we'll replace cosine squared with this. So where we had cosine squared, we're going to put 1 minus sine squared. So 1 minus sine squared of x. Do bring this x along. Don't forget the x. Even though sine of x is kind of a package deal. All right, so let's clean that up, distributing the 2. 2 minus 2 sine squared x minus sine x equals 1. Now we need to use some quadratic factoring. This is a quadratic equation. It's in that form. So let's set it equal to 0 in order to use our techniques for quadratic equations. So let's subtract 2, okay, and we get negative 2 sine squared x minus sine x equals negative 1. And now let's get these, move them over to the right so we can make them positive. Let's add 2 sine x, sine squared x, and add sine x, okay? So we're going to add these over, move them over to the right side, and we end up with 0 equals 2 sine squared x plus sine x minus 1. All right, so this is in quadratic form. Notice that this is sine x squared and sine x, okay? So we're going to factor this, kind of treat sine x as the variable, even though it's got a little bit more to it. So we need to factor this. Quadratic factoring. We need the first two terms to multiply to 2 sine x squared, sine squared. So since we have a nice prime number there, 2 is a prime number, we know that one of them has to be sine x and one of them has to be 2 sine x. These two things multiply to that term. Now we need these two numbers to multiply to negative 1. Well, we know one of them has to be positive 1, one of them has to be negative 1. Which one is which? Is this negative? Is this positive? Well, we can check. Negative 1 times sine x is negative sine x. And 2 sine x times 1. I'm thinking about simplifying. Does this guy here simplify to make what we had up above? And it does. If you FOIL this out, we get 2 sine x minus 1 sine x, and that adds to just a positive 1 sine x. So this does simplify. So we got it. We got it factored. So now we need to break this into two parts, because either this first part equals 0 or the second part equals 0. So that's where we're going next. So we break it into two equations, and we're going to solve them. So we got solving the left one, we got 2 sine x equals 1, add the 1, divide by 2. And now x is the inverse sine of 1/2. So we'll think about where that is. Unit circle. Okay, and so that unit circle ends up, sine of 1/2 is over here. We saw that last time. And here, sine x equals negative 1, so x is the inverse sine of negative 1. And the inverse sine of negative 1 times the y value is going to be down here. So our solutions are x equals, this guy right here, that's pi over 6. This guy right here, that's 5 pi over 6. And this guy down here is 3 pi over 2. And that's our answer. Let's see if we can write that nicer. All right. So we have 3 possible answers. So we have different techniques. To start with, simplify as much as possible. Get that expression by itself if you can, and solve it. If you can't get that expression by itself, you may need to factor the first and make two equations. All right, before you factor, set it equal to 0. All right, so try those out. See what you can do. Good luck.